Hello everybody, and welcome to the Poor Man's Chemist. In this video, I am going to be making a copper chromite decarboxylation catalyst. Basically exactly the same prep that Doug's lab demonstrated several years ago. Unfortunately, Doug doesn't make videos anymore for some reason. I have no idea why. His channel is pretty fucking awesome though. And if you don't know about Doug's lab, you should still go check it out because there's still a nice library of awesome practical chemistry instruction there. But anyway, he made and then demonstrated the use of a catalyst. In his case, he used it to decarboxylate niacin to produce pyridine, and it was copper chromite. Happily, I have all of the stuff that I need to make this little beast, and I am going to use it to decarboxylate benzoic acid so that I can make benzaldehyde. There is a prep that I want to do of conversion of benzyl alcohol to benzaldehyde using barium manganate. This same thing can be done with bispyridine silver 1 permanganate. Basically what these are less active versions of permanganate. So you don't get over-oxidation. It's supposed to, according to the papers, they both give you very high yields, but one of the things that helps to keep the manganese tame is that it's done in a benzene solvent. Everything is very carefully dried and water is very carefully excluded from everything so that you don't get over-oxidation. I don't know if a lot of people know this or not, but one of the reasons you get that, especially if you're trying to oxidize an alcohol to an aldehyde, it can over-oxidize to a benzoic acid if you've got water around. But if you remove water from the equation, it's a hell of a lot easier to get the aldehyde. So, barium manganate, which is the one we're going to go with, is supposed to give us a 95% yield. Converting benzyl alcohol to benzaldehyde. Bispyridine silver 1 permanganate is supposed to give us, I think, 100% yield. I think both of these reagents will also convert benzylamine into benzaldehyde in very high yield. I don't know why you would have benzylamine just laying around, but if you did. But both of them use a benzene solvent, so we need some benzene. I've only got about 20 mils of it, so I need more of it. And now that I've spent almost 3 minutes talking about why we're doing this, let us proceed. Now, what we have here is 12.6 grams of ammonium dichromate. This is the same stuff you use for the volcano demonstrations, And we have 25 grams of copper sulfate pentahydrate that was sent to me by a subscriber. I had to grind it up, but it is reagent grade and is very pure, and I very much so appreciate him sending it to me. Now, what we need to do is we need to create solutions of these two things, and then we need to create 42 mils of 10% aqueous ammonia. I made some aqueous ammonia a while back, but this label is now a lie. It's a lying label because ammonia solutions, especially really concentrated ones like this one, started out being, degas ammonia over time, and this is several months old. So after an hour's worth of work hunting for fucking specific gravity tables for aqueous ammonia yesterday, that was fun, I figured out that this is about 17%. So we just need to dilute that down to make 42 mils of a 10% solution. So anyway, let's go ahead and let's get our solutions going here. Well, to save time on the video, what I'm going to do is I'll prepare these solutions and I'll come back when they're ready to go and we are ready to start mixing shit together. How about that? All right, so on the copy of the protocol that I wrote down from Doug's video years ago, it says that these things need to be hot. I don't want to go back and watch his video and just repeat it beat for beat. So I'm just going to use the written protocol that I wrote, and I think it'll be fine. So, besides, I did have to heat everything up to get it to go into solution. Now, the next thing that we need to do is we need to take our solution of ammonium dichromate that we have here, and we need to combine it with our 42 mils of 10% ammonia that I have made up here in order to create ammonium chromate. Obviously I can't, like Doug did in his video, add this to this, so I'm going to switch it around and add this to this. However, I would like to get the stir bar out of here first and transfer it over. And how are we gonna do this? Let's see. Just like that. Alright. Don't touch the hexavalent chromium, kids. Okay. Now, I don't know, I mean, obviously we don't want the ammonia to get too hot, but I think it'll be fine because we're going to do this kind of quickly. I'm going to have to move you at kind of a weird angle so that I can get in here to do this. Okay. Alright. So, here we go. Come on, stir bar. Alright, that was nice and painless. My big fucking hand in the way, like it was in the tetrachloroiodate video. Right as it changes colors, my big fucking hand in the way. It's like, son of a bitch. Okay. Yeah, how you guys like that for a stir bar retriever? Every time a stir plate fucking breaks irreparably or anything else becomes useless, I harvest the magnets out of it and just keep adding them to the stack. That thing can probably move a stir bar from the other side of the bench at this point. Alright, so we have ammonium chromate. Very nice. Well, you can tell by the change in color and how it went all yellow. So, there we go. Alright, let us consult my written instructions here. I'm trying to be a hell of a lot better about actually keeping lab notes. See, for the last several years, I've just like used my videos as notes. I haven't actually written anything down. I know, I'm such a bad chemist. So I'm trying to be better about that. So let's see. Now we, oh, hello. Add the ammonium chromate to the copper sulfate solution, and the reaction is exothermic. Okay. Weird angle again. Here we go. Okay, come on. There we go. All right. Use our giant magnet stack to hold on to our stir bar. And we're supposed to do this slowly. Let's zoom in a little bit so we can see the drama a little better. Okay. Yeah, sure, we'll go with that. Ooh, pretty. Oh, clumpy. Okay. Come on, stir bar. Work with me here. Ah, shit. Come on. Alright. Maybe that's something to stir that fucker with. Someone pointed out in a previous video that I was using thermometers to stir stuff. And you know what? They were absolutely right. You shouldn't use thermometers to stir things. Okay. All right. Well, that worked out. Okay. Now, Doug's instructions were to stir this fucker for 5 minutes to let the reaction go to completion. Looks like we got a nice precipitate. I'm not too worried about the little bit of extra water here. All right, I'll be back in 5 minutes. Okay, everybody. So there we have it, our copper ammonium chromate. And in his video, Doug had said that this stuff could be hard to filter, and he had one hell of a time doing it. I went into this all ready for this to be a monumental pain in the ass. I had the easiest fucking time filtering this. Now, I was like, I pre-wet the filter paper, man, laid it over the holes, already had a vacuum going. I was ready for a fight. And this thing filtered out extremely easily. You can see we have a nice green filtrate. Green, of course, being the color of reduced chromium. That being the case, I think that this is fine to just dispose of normally because there shouldn't be any hexavalent chromium left in it. At least I don't think. So the next step is to take this stuff, put it in an evaporating dish, which I have over here, and dry it. It says to dry it to the point where you can actually crush it up, then to dry it some more. Then we've got to heat it to 400 degrees C in order to calcine this to get our copper chromite. So I will get this on there to start drying out, and I will come back when there's something to report. Okay, so I decided that trying to dry this over boiling water was kind of dumb. Because there's just so fucking much of it, man. I mean, trying to do that just seems like we're going to be punishing ourselves. Especially because, I mean, look how much of this shit there is. I mean, there's a lot of this stuff here. So I reasoned, I mean, why not just put it in the toaster oven, put this fucker on about 275 Fahrenheit, and then just dry it out that way. And it seems to be working just fine. Doug instructs us to take it, once it's most of the way dry, pulverize it, and then continue to dry it. So that's what I've done. It's still kind of damp, so it's still got a ways to go. It's been going for about an hour now. We'll let it go for about another hour, I guess, and hit it again. It does like to stick, so be careful. I'm going to grind this off the bottom here a little bit without trying to scratch up the glaze because we don't need any silica in it. So anyway, back into the oven it goes. Okay, people. I had to keep it covered up so that no fucking leaves fell into it. This is our dried and powdered stuff. I put it through a mesh screen so it would be nice and finely pulverized. And now we need to calcine this down to crude copper chromite. And to do this, we're going to have to heat it up to about 400 degrees C. However, we have a minor problem. The crucible that I was going to use for this is cracked, and it was the only one that I had that was large enough to do this in. I'm going to have to get another one. Fun. So, going to have to improvise this, and I think what we're going to do is we're going to do it in this porcelain dish over a flame, and we are going to use a cast iron pan to redistribute the heat and even it out some, and then we are going to pray that this thing will not crack. Really gonna hope that it doesn't crack. Oh my god. Yeah. The redneck is strong at this point, kiddies, so we're just gonna have to go with it and see what happens. So here we go. God, I hope this works. Okay, somehow my phone didn't start recording when I hit it. Piece of shit. But I took our nice black as night calcium crude copper chromite catalyst, transferred it to a beaker, added in 130 mils of 10% acetic acid, and it needs to stir for 10 minutes. Then we stop the stirring, let it settle, decant off the supernatant liquid, and then wash it with another 130 mils of 10% acetic acid. So I am going to do that, and I will come back when those 2 washings are done. All right, everyone. So this is our double acid washed and very thoroughly rinsed with deionized water powder. This should be our pure copper chromite catalyst. What we need to do now is dry this thing out. Doug did it over boiling water once again, but just like before, we are going to use the toaster oven because it is far more efficient. I'll tell you what, I just got another comment from somebody on the hydrobromic acid video. This video is bad technique. Using PP. I swear, man, it never ends. Here, look, I'm touching it without gloves. Oh my God. Oh my God, I can feel the life edging out of me. Okay, so I'm gonna go take this, dry this at a low temperature. Doug did it over boiling water. We're gonna do just like we did before, about 275 Fahrenheit. And because my toaster oven is kind of a piece of shit, that'll probably be about, just slightly above boiling. So I will come back when this fucker is dry. All right, guys, there we go. There is our copper chromite decarboxylation catalyst. Neat. I have been meaning to do this forever. This was a lot easier than I thought it was going to be. It was very painless. I was surprised by that because the way Doug was talking, it sounded like it would be a pain in the ass prep, but it was anything but. Always a nice surprise, right? So anyway, if you guys like that video, give it a thumbs up, subscribe, comment, share the video, donate a few bucks if you're enjoying this content. It is expensive content to make. And until the next one, you guys, I will see you later.